Hi everyone. This video presents a term project on application-aware network management using software-defined networking in Pyretic. Now we'll go to the objectives of the project. The main objective is to make network management easier using SDN by defining dynamic policies on the controller. There are three main policies that we wanted to implement.
Hi everyone.
First, we implement traffic separation based on the application. Next, we implement a scenario where a data cap is enforced on traffic. So as soon as the data cap limit is reached, we drop the packets of the flow.
By Abhinaya Venkatesan.
We implemented this at both
Abhishek Naik,
the packet and
Jyothsna
at the byte
Suresh,
level.
and
Finally,
Santosh Prabhu.
we block traffic from specific
Now we move on
ASs.
to the objectives of this project.
The topology consists of
The main
4
objective
hosts, which we
is to
assume
make
to be
network
4
management
different
easier
ASs, all
using
connected
SDN.
via a switch.
By
There is a controller on top of
dynamic
the switch,
policies on the controller.
and we have implemented all our policies on
The
AS2.
main goal of the project is to simplify
Now let's
policy
suppose
implementation
an AS,
among
say AS2,
ASs.
has an agreement with
So there
another
are three
AS,
main policies
AS1,
that we
to
implement
only
for
allow video traffic from
First,
AS1.
we implement traffic
We
separation
implemented this policy
based
on the
the
controller,
application.
as you can see
For
in the demo.
example,
We have simulated
and
video
UDP
traffic
flows
using
are
UDP
separated,
flows and
and
regular
one of
data
them
traffic
can be
using
blocked.
TCP flows.
Next, we implement
We
a
first get the
scenario
Pyretic
where
controller
the data
running.
cap is enforced on the traffic.
After this, we
So
create
as
the
soon as
topology.
the data cap limit is reached, we drop the
Now,
packets of the flow.
we simulate a UDP flow
We
from
implemented
AS1
this at
using
both
iPerf.
the packet level and at the byte level.
We
Finally,
initialize
we block traffic
Wireshark on
from
AS2
specific ASs.
to monitor the packets received.
These could be malicious ASs in the real world. The topology consists of 4 hosts, which we assume to be 4 different ASs, and they are all connected via
When
a
we
switch.
start the iPerf,
There
we
is a
see that the
controller on
UDP
top of the
packets are
switch.
received by AS2.
SDN gives the controller direct control over the underlying switches through a standard API like OpenFlow.
Now we simulate a
We have implemented all our policies on AS2.
Now we simulate a TCP flow
Now,
from
let's
AS1
suppose
using
an AS,
iPerf.
say AS2,
We see that the
has an
TCP
agreement with
flow is
another
getting
AS,
blocked as
say
expected.
AS1, to only
Therefore,
allow
our
video
first
traffic
policy
from
has been
AS1.
implemented successfully.
We implemented this policy.
The
on
second policy
controller,
that we
as you
implement
can see
is a
in the
data
demo.
cap on video traffic coming to AS2
We have
from
simulated
AS3.
video traffic using UDP
This policy
flows
limits
and
the
regular
video
data
traffic
traffic
coming
using
from
TCP
AS3
flows.
to
We first
20
let the
packets,
Pyretic
after
controller
which it is blocked. So again, we get start
After this,
the Pyretic
we
controller
create the topology.
and initialize the topology.
Now we are going to simulate
we start a UDP flow
from AS1
AS3.
using iPerf.
As
We initialize
expected,
Wireshark on
the
AS2
UDP flow is
to
blocked
monitor the
after
packets
sending
received.
20 packets. There are some excess packets sent
When we start
because
the iPerf,
by the time the policy is
we see
implemented,
that
some
the
packets
UDP
have already
packets
been
are
forwarded
received
to
by
AS2. This is a classic example of the poor flow consistency issue discussed in class. So a second policy has also been implemented successfully. Now, finally,
simulated
for the
TCP
third
flow.
policy,
This video
from
presents
AS1
term
using
project
IS4
on
is a malicious
application-aware
AS.
network management.
The
We see
packets
that
from
the
software
autonomous
autonomous
is
was
getting
getting
blocked
blocked
as
as
expected.
by AS2.
Therefore, our first
This
policy
project
that
has
has been
been
created
iPerf
by
successful.
Abhinaya Venkatesan, Abhishek
The second
Naik,
policy that we
Jyothsna Suresh is a data cap
and
on video
Santosh Prabhu.
traffic.
We see that
coming
the
to
iPerf
AS2.
packets
Now
from
we move on to the
ASCP or
objectives of
UDP
this project.
initialized
This policy
by AS4
limits the
main
video
objective
traffic
being
coming
received
by
by
network
AS3
management
to
easier
20 packets
using
after
SDN.
which
Now we move on to the
analysis of the
dynamic
So now
policies
again,
on the control.
we find that the
start
policies
Pyretic
that we
controller.
implemented
The
are
main goal
suitable
of the
for all
project
types
is
of
to
policies.
simplify policy
One of the
implementation
observations that we
amongst
made
ASs.
was that there
we
was
start
some
a UDP
excess
flow.
traffic
From
from
main
AS beyond
policies that
the
we
data
implement
cap
for
for a UDP flow.
First,
This,
we
as we
implement
mentioned
traffic
before,
separation
is because the
based
time
as
for the
expected.
policy
The
to
UDP
actually
flow
get
is
implemented.
blocked after
And
sending
during this
and
time,
UDP
20
packets
packets
are
still
separated.
subject to the earlier
And there are
policy,
some excess
which is to
packets
forward all of them.
because by the
And
time the
therefore,
policy
they are
is
forwarded
implemented
by
a
AS
scenario
instead of
packet
getting
where a
already
data cap is
forwarded to
enforced on the
AS2.
traffic. This is a
So as
classic
soon as
also
the implemented
of
the
the poor
data
flow
caps at the
consistency
byte
drop
level
the packets
where the
discussed in
flow
class.
is dropped once
So
divided
our
on
second
second
policy
policy
now
now
has also been
we
implemented
found that this was
successfully
enforced
at the byte
more
level.
accurately
Finally,
than
for the
using
third
finally,
policy, we block
have
traffic
assumed
from
that
specific
AS4
AS is a malicious
Usually,
AS. These could be malicious
the packets
AS
from
from
data
this
caps
AS
are
are
implemented
dropped by
using
AS2.
bytes. But we
Again,
wanted
the
to run the
topology
byte
consists
examine
of
how
four
the packets
which we
and
assume to be
four
initialized
different
ASs,
topologies
and they are
dropped
all
or
connected
forwarded.
via a switch. There is a controller on top of the TCP and UDP flows
SDN
from
gives the
AS4 to
controller
AS2
direct
simultaneously over the underlying switches through a standard API. We see that the IPERF packets, be it TCP or UDP, all our policies by AS4 are not being received by AS2. Now we also run a ping test, say from AS4 has an agreement with another AS, say AS1, and we can see that to only allow video traffic from AS1. Now we move on to the analysis of this policy on the controller. We find that the policies which we implemented are suitable for all types of traffic. We have simulated video traffic. One of the observations UDP flows and regular there was some excess traffic TCP flow beyond the data cap for a UDP first flow. Get the piratic controller this, as we mentioned before, is because of the time taken for the policy after this to actually create the topology. And during this time, packets are still subject. We are going to simulate a UDP flow and from AS1 are forwarded to the AS. Instead, we initialize Wireshark on AS2. We also monitor the packets received data cap at the byte level, where a flow is dropped once the byte count has reached a limit. We found that the UDP packets are received more accurately than using packets. Usually, this is how data caps are implemented. That is at the byte level rather at the megabyte or gigabyte level. And for big organizations, we simulated TCP flow at the terabyte from AS1 using IPERF. We wanted to implement this at packet level to compare and see that how long it takes for the policy to take expected. Therefore, our first policy has been implemented because of the latency involved in policy implementation. The second policy that we implement 25 packets were sent on video instead of 20. Coming to AS2, however, from AS3, at the byte level, the flow was policy as soon as the video traffic, the 1000 byte limit that we had to 20 packets, after which as far as scalability is concerned, it is so now again that as the number of sender hosts increase, the latency for implementing the topology policy might end up increasing the number of packets that escape that start a UDP flow from AS3. Hence, we were able to implement all the policies that we had aimed for. This is, however, expected, just that the UDP of the flow is blocked after sending 25 packets. Thank you. There are some excess packets sent because by the time the policy is implemented, some packets have already been forwarded to AS2. This is a classic example of the per flow consistency issue that we discussed in class. So, our second policy now has also been implemented successfully. Finally, for the third policy, we have assumed that AS4 is a malicious AS. The packets from this AS are dropped by AS2. Again, we run the piratic controller and we initialize the topology. We initiate TCP and UDP flows from AS4 to AS2 simultaneously. We see that the IPERF packets, be it TCP or UDP, initialized by AS4 are not being received by AS2. We also run a ping test from AS4 to AS2 and we can see that AS2 is not reachable. Now we move on to the analysis of our project. We find that the policies which we implemented are suitable for all types of traffic. One of the observations that we made was that there was some excess traffic beyond the data cap for a UDP flow. This, as we mentioned before, is because of the time taken for the policy to actually get implemented, and during this time, packets are still subject to the earlier policy and so are forwarded to the AS instead of getting dropped. We also implemented the data cap at the byte level, where a flow is dropped once the byte count has reached a limit. We found that this was enforced more accurately than using packets. Usually this is how data caps are implemented, that is at the byte level rather at the megabyte or gigabyte level, and for big organizations like Georgia Tech at the terabyte level. We wanted to implement this at packet level to compare and see how long it takes for the policy to take effect. We saw from the simulations that because of the latency involved in policy implementation at the packet level, 25 packets were sent instead of 20. However, at the byte level, the flow was dropped as soon as it reached the 1000 byte limit that we had marked. As far as scalability is concerned, it is intuitive that as the number of sender hosts increase, the latency for implementing each policy might end up increasing the number of packets that escape that policy. Hence, we were able to implement all the policies that we had aimed for. This is, however, just the tip of the iceberg, that is STM. Hope you guys liked it. Thank you.